So my name's Elton. I work for Docker. Thank you for coming to this session. I should point out that right now, in another room, there's a session about finding life on other planets. If you'd rather go to that, I will not be offended. I was tempted to go myself, but I've got to be here to do this. So I'm talking about reverse proxies, which is a slightly unusual topic for a conference because it's not new technology. So reverse proxies, the architecture, the features, all that stuff's been around for a long time. Why it's important now is because in modern architectures, reverse proxies play a much more important role. So I'm going to cover, that's what I'm going to be covering today. So there's three main things I'm going to go through. I'm going to go through what a reverse proxy does, why it's there, where it fits in, and what it can do, and what patterns it kind of unlocks. And then I've got a bunch of demos. I'm going to show two different approaches for this. So two of the most well-known technologies in this area are Nginx, which is a server that's been around for a very long time, and Traefik, which might be pronounced traffic, I'm not entirely sure, which is a more modern approach. They both do broadly similar things, but they plug in with the architecture in different ways. So that's what the demos will be. OK, so first of all, a reverse proxy is a network component. It's like an infrastructure level component. It's the opposite of a proxy that you would have in your corporate network. So in your corporate network, when you're there with your browser and you go to docker.com or my website or the Kubernetes website, which are the only three websites you really need nowadays, if you go to those, it kind of feels like you're going directly to their servers, but actually you're not. You're going through a middleman. You're going through a middle component, which is a proxy, a network proxy. All your traffic goes through there, and it makes the calls to the downstream components. And the purpose of that middle thing is it's a really powerful unit because all the traffic flows through it. You can do good stuff when everything goes through that central component. Some of the things you're going to get in there are policies to say whether or not you're allowed to go to certain websites and how much time you're allowed to spend on those websites. You've got auditing, so everything you do can be tracked, which might be important in your next performance review. And then you've got, slightly less sinister, you've got caching. So if you've got hundreds of developers that are all going to the Kubernetes website to try and work out where to start, there's no point sending all that traffic directly to their servers. The first person who goes and browses to a particular document on the Kubernetes website, it can be cached inside the network proxy, so the next 100 people who go and browse, it comes from the local network. It doesn't have to go out to the outside world. Better performance, better bandwidth usage. A reverse proxy is the same thing in reverse. So when you own a whole bunch of web properties, you can either expose them all directly, so users come and they browse directly to your website. The disadvantage with that is there's a whole bunch of concerns that then you have to be present in every one of those properties. So they all have to be publicly available on the internet. They all need SSL. They all need to deal with things like caching and hardening their availability, all that sort of stuff. If you put a reverse proxy in between, then it's the opposite of what happens with your network proxy. All the traffic comes into this central component that you own, and it fetches stuff from the upstream components, from your own web applications. And the beauty of that is, again, it's a very powerful component that can do a lot of stuff. It can do a lot of the same stuff. So I can have policies here, but they work in reverse. I can do things like rate limiting. So I can protect myself against denial of service attacks by putting rate limiting policies here for traffic that's coming in to my properties. I can do auditing to see where all this stuff comes from, and I can do caching. And caching of my own stuff here, which reduces the amount of traffic that goes to my end applications. So when a user comes in and browses to my blog, the first time the proxy cache is going to go and fetch it directly from my application, but then it will store it in local disk or memory, and the next person that comes in, it won't have to touch any of my actual application code. But you can do way, way more than that stuff. You can do routing. So here I've only got one public entry point. The proxy is the only thing that's listening on the internet. That's the only thing I need to harden, and I can do my SSL termination in there. So all my HTTPS certificates live inside the proxy. I don't need to worry about any of that infrastructure level stuff in my application configuration. All these things are very simple. They just produce plain HTTP. They don't have to worry about headers, HTTP headers to help client caching. All that stuff can be done in the reverse proxy. And load balancing between all these things, and routing. So a single entry point, depending on the request where it comes in, it will fetch it from the relevant place upstream. So what that looks like in a containerized world is I'm running, this is why it's now important, because there are some patterns that unlock with modern architectures. So I can run my reverse proxy in a container. This dotted line is my container platform. The reverse proxy is the only thing that's publicly available. That's the thing that's got an exposed port. Traffic's coming into my container. And all the other stuff that I've got behind there is now a private component. So I can run if I've got several properties that I own, I can have a container with some workshop content that's listening on this public URI. And I can have my blog, and I can have some other things. 3 completely separate applications. They're all internal. The only thing that's public is the reverse proxy, and it's got a bunch of routing rules that say when a request comes in from a browser for this particular host name, I'm going to fetch it from this particular container. So multiple domains from a single cluster. The second thing that it unlocks is microservice architectures. So when you're doing highly distributed systems, again, the only thing that's public is my website. Maybe that's fetching things from lots of different microservices. So in this case, my reverse proxy is kind of protecting everything that is part of the application and only exposing the public thing that I want to be exposed. But maybe one of my APIs is going to go public because I want to make that available to end users. All I do is put a new rule in the proxy, and suddenly that's available at whatever URL I want. So I can expose selectively parts of my microservice architecture and make them all available. And the last one, which is probably the most boring but the most useful, is if you're taking big, ugly, monolithic applications and you wedge them in a container and you run them in Kubernetes. And that's fine, because you can do that stuff, and it gets you some of the advantages of a modern architecture, but you've still got this 2 million line monolith that's running in a container. If you want to work on new features or change existing features, there's still a 10-day regression test cycle. But by putting a reverse proxy in there, not only am I protecting my monolith, so this doesn't need to be hardened code to such an extent because it's a private component, but also I can add new features in separate containers. So I can put some new feature in there, use a completely different technology stack, and just do whatever I need to do in that feature, and then that has got its own release cadence. So my monolith might get updated once every 6 months, but as I'm breaking features out, they can be deployed and scaled up independently of the main unit. They don't need to go through all the regression testing. Okay, so demos. Nginx is the component, one of the most popular components here. It's been around for a long time. It does lots of different stuff. It's actually an HTTP server. It's not just a reverse proxy. It can be a website. So you can package up Nginx with a whole bunch of static content, and it will publish that stuff for you. It can also be a front end to PHP, but no one put their hand up this morning about PHP, so I'm not going to talk about that. It's very fast. It's very lightweight. It's very popular. It works on a kind of static configuration file. So it can run anywhere because it was originally designed in the world of servers and VMs. You have this configuration file that basically describes all the routes that you care about. So here's the incoming request for blog.sixside.com. You're going to go and fetch that from the upstream called Sixside. That may be a container, it may be a VM, it may be a load balancer over a bunch of containers. But it's a static file that lives alongside Nginx with all the rules. You can containerize it really easily. Because it's lightweight and it's cross-platform, you can package it in a container with your static configuration file and throw that thing up in your Docker cluster or your Kubernetes cluster. It's open source, it's free to use. There is a commercial version as well. So standard model, I can use the open source one and I own the maintenance, or I can pay and I can have support. So it looks like this in the architecture, very similar. I've just labeled it as Nginx, and packaged up in there is my nginx.conf file. That's that static configuration file that lists all the routing and all the features that you want to enlist. It works on the network level. So it doesn't understand about containers. It doesn't know if it's running in Docker. It doesn't care about any of that stuff. All I'm doing in my nginx conf file is saying, here's the host name that I'm listening on, sixside.com, and here's the DNS name of where you're fetching the content from, which could be a container, it could be a VM. It doesn't care. It works on the network level. Okay, so demos. All my demos here are up on GitHub, and at the end I've got a slide that shows you how you can get them. All you need to run them is Docker Desktop. So I've got Docker Desktop installed, which is on Mac or Windows, and you can turn on Kubernetes, and you can have a single node Kubernetes cluster. It's really simple. So I'm going to show you how Nginx works first of all, but I'm going to show you the features that you get. So the first feature that is the most useful is caching. So I can cache the content that comes from my application and reduce the amount of end-user traffic that hits my app. So if I open my terminal here, I'm going to run a really simple app just as a Docker container to start with. So no proxy at the moment. This is just an ordinary web application. So this is a fairly noddy application. Let's zoom in a little bit. It calculates pi to any decimal places that you need, within reason, obviously. So I can say I want 1,000, or I want 10,000. or I want 20,000. This is all on Docker Hub. If you need to use this in your organization, it's free to use. If you need to calculate pi to 20,000 decimal places. 20,000 or more, it takes a little while. So what I've got here is it's telling me how many decimal places. That's the result, obviously. It tells me it took 0.7 of a second to calculate. Now, if another user comes in and makes the same request, it's going to get calculated again. It still takes another 0.7 second. But the end result is exactly the same because it's never going to vary. This is where a cache would be nice. But rather than go into my application code and start wedging in a load of cache, I can do that with my reverse proxy. So let's go back to my demo. Over here. And if I show you the Nginx configuration, I'm not going to do like a massive deep dive into this stuff, but I will show you what it looks like. This is the static configuration file I was talking about. Nginx works on these server blocks. So a server is a definition of a routing rule, basically. This is saying that I'm listening for anything that comes in on the location slash, like the base entry point. I'm going to be serving it from a proxy of http://pi. So that's the name of the upstream server. So it's going to go to the DNS name for the Pi web server, and it's going to get the content from there. All this other stuff is about how it uses the cache. So it will fetch that content from the Pi server. It will store it in its local cache. There's configuration here telling it how much memory to use, how much disk to use, how long the cache can stay alive for, all sorts of stuff like that. The other things I've got in here are I'm enabling gzip. So again, inside my application code, I'm not supporting zip compression because I don't get that by default from my application platform, but I can turn that on in the proxy. So if the browser accepts gzip, I can compress my output without having to do anything in my application code. And the final thing to point out is that I'm telling Nginx it can use its cache even if it can't get to the upstream. So if my container is dead and my application is no longer available, but Nginx has the response in its cache, it can send that back. So it's not going to worry about not being able to reach the upstream all the time. Okay, that's about as quick as a run-through of an Nginx configuration file as you can get, really. So in order to run that, I've got my, that's not the right one. Come back here. I've got a Docker Compose file, which is going to run both those components in containers. So I've got my Pi application. That's the same container I've just run, but it's a private component now. I'm not publishing any ports. It's not accessible to the outside world. The only thing that is accessible is Nginx, which is listening on port 80. So any traffic that comes into my machine on port 80 gets sent to the container. The container then looks up the configuration file, which gets passed to it here, and it will act on the traffic there. This is the DNS name. Pi is the DNS name of my container, so that's where Nginx will get the upstream from. That's the thing it's going to be proxying. Okay, so when I deploy this, it's just by using Docker Compose up. Let's get rid of that first one. And this will start up the same web application, but now with the reverse proxy as well. Okay, so if I go back to my browser, the tab key on my Mac doesn't work all the time, which makes demos quite difficult because you're swapping all the time. Okay, so if we go to localhost, end user result is exactly the same. So if I'm the user of this, I don't see any real difference. If I'm a techie and I dig deep and look at the network, and I'm not sure I can zoom into this, but you'll have to trust me for it. If I look at the network and replay that message, then down in here, I can see there's a few other bits and pieces. You can't see it, but there's a cache header that says I loaded this from the cache rather than going to the upstream, and it tells me it's coming from Nginx. So Nginx is the public thing, not my web server. The important thing is if I go and look at a particularly long one, like 20,000 again, first of all, it takes a second to calculate. That from is the name of the container. That's the host name that it's been served from. If I repeat that, it comes back instantly. So that's come from the cache. So that Nginx has cached that. My application didn't see that request at all. Got handled by the reverse proxy in its entirety because everything it needed was in its own local cache, which is where one of these things is really useful for offloading some of the content that your application has, especially static content. Like if you've got a Node application or .NET Core or whatever, there's no need for that stuff to be serving CSS files or JavaScript files. Your reverse proxy can do that for you. Okay. So the other thing that's very good here is I can kill my application. So I've got two containers running. One is for Nginx, and one is for my application. If I kill the Pi container, if I spell Docker correctly, I must type Docker like 10,000 times a day. OK, all I've got running is my proxy. Now, if I go back to my web application, and I repeat that call, I still get the same content. It's come from the cache. Anything that was in the cache, I will be able to see. So my local host, the root, that comes through, that's fine. If I try and browse something which isn't in the cache, then eventually I'm going to get an error, because now Nginx is trying to find that Pi web server. There's no container there. Ultimately, it'll time out, and then it'll throw back, and it'll give me a 502 or something, telling me that it can't find anything to give it the content, because it doesn't have that in the cache. This will come back in a second. Now, the other thing I can do, there we are, bad gateway, which is telling me that I tried to go somewhere to get the content, but nothing happened. There was nothing there, so I'm coming back. OK, and the last thing I can do with this particular demo is I can scale up. So right now, I don't have any containers for my Pi web application. Don't do that. If I scale up, I can create 3 of those. And now there are 3 containers that all part of that same domain name. So Docker and Kubernetes, if you're not familiar with it, everything is done in the same sort of network style that you're used to. So containers find each other by their DNS name. If there are multiple containers under that DNS name, then you can kind of round robin the requests between them. So by having 3 of these, Nginx will load balance across my web containers, my application containers. So if I go in here, and now I request this one again, so I get a response. It took 7 milliseconds. It came from this container, 382. If I repeat that, obviously it's going to come from 382 again, because that's now in my cache. If I look for something different, it'll come from a different container. So this comes from 1C7. The next one will come from the next one again. And ultimately, it does all the load balancing for me. So it does the routing. It knows how to find things. It can cache the response. And it can load balance between them, which is all pretty important stuff, given that there isn't very much in that Nginx configuration file to make that happen. OK, so the next one, sticking with Nginx, is that it can host multiple sites. So I'm going to kill everything I've got running at the moment. I'm going to run a different application, which I regret to say is a to-do list. And I know that they're the most tedious things you can possibly demo, but they're incredibly easy to write, especially if, like this to-do list, you don't let any items ever get deleted. It makes the code much easier. So this is my to-do list, which shouldn't look like that. It should look like that. You can add stuff in here, and you know what these things look like. If I want to run this alongside my Pi web application, I can't do that on a single server, because they're both listening on port 80. And I can only have one thing listening on port 80, which is just as true in Kubernetes and Docker as it is with individual processes. So if I want something to be able to host both those, then I need something in between, which is my reverse proxy. So that's where Nginx comes back in. I've got another Nginx configuration file here. The first part is the same. So this is my Pi web application. I'm still going to be hosting that. But in order to be able to serve both domains, Nginx needs to know what the incoming host name is, so it can send the right response and fetch it from the right place. So I've got an extra thing in here which says, this is the server name. So when I make a request, an HTTP request, inside that request there's a header that says, this is the host I'm looking for. When I browse to http pi.local, there'll be a pi.local request header. And Nginx looks at that and says, well, this is the server that's going to get me the response for that particular host. So all I've done is change that in here. I've got another server block for my to-do application, which is mostly the same. It's saying if the incoming request is for to-do.local, you're going to get it from the to-do container or the to-do server. Nginx doesn't really care. And that's going to give me my HTTP response. But actually, my to-do application uses sockets, uses WebSockets. And that's a slightly different type of HTTP connection, which is fine, because I can configure different aspects of my application to work in different ways through the proxy. So my WebSockets, I just want it to go straight through, and I need to have a slightly different connection configuration. So this is saying the default location, any path you request, you can go straight from that container. But if you look for the _blazer, which is my WebSockets, then I'm going to talk to the downstream container in a slightly different way. So I can configure different things. Different paths could have caching or not caching. I can set things up however I want to within the routing of my application. As long as I can specify a path to it, I can configure it in a different way. OK, and then the compose file for this, it's just the same. So I've got my Pi application in one container, my to-do application in another container, and then a container for Nginx. So none of that's changed apart from the new container being in there. So if I start this up, let's get rid of the one that's already there. So I've got that single container running, so I'll get rid of that. I'll start them both up. So it's going to be my Pi application, my to-do application, and my proxy. And then in order for this to work, I need to have pi.local actually resolving somewhere. So in the real world, I'll have a real DNS name with a real DNS server. Because it's a local demo application, I put that in my host file. So in my host file here, I've already specified that these addresses are all going to come to my local machine. So it will still pass the header information in the HTTP request, but ultimately resolve to my local machine. OK, so now I can browse to those same applications again. And they're going to be just as boring, but now they're coming from the same entry point. So pi.local, exactly the same thing, and the same with to-do.local. This one takes a few more seconds to fire up. But the initial request is coming into Nginx. Nginx is going then passing it to the upstream. And because the communication here between the website and the server is all through WebSockets, if that wasn't working correctly, then I wouldn't be able to put stuff in here. But that's all fine. So it's all kind of working as I want to. So I'm doing different things with each of those reverse proxies. I've got one entry point, but for my Pi application, I've got caching configured. For my to-do list, I've got separate configuration for the ordinary serving of the HTTP and for the WebSockets that power the communication between server and client. OK, one last demo for Nginx, which is SSL. So one of the most powerful things here is that I'm offloading more and more infrastructure level responsibility away from my application code, my application setup, into this central component, into my reverse proxy. And I can do that with my SSL configuration too. So let's kill all these things out here. So the last app I'm going to show, and again, I'm going to run it natively first. So this is Ghost, which is a blogging platform, which is a pretty cool blogging platform. It uses this weird port 2368, and it takes a few seconds to start. If you wanted to publish my Pi application, it probably doesn't need to be HTTPS. My to-do app, there's going to be authorization at some stage, so it will need to be HTTPS. And my blog certainly will need to be secure because there's authorization to be able to go and publish as well as to read. So this is just the native Ghost container with a bunch of default stuff in here. I can read these. These are individual posts. It's all being served directly from the container. If I browse to the /ghost endpoint, then that's the authoring endpoint. So I can set things up and publish stuff. I don't necessarily want everyone to be able to do that. So when I add Ghost into my Nginx configuration, point this here. Again, I've got the same sort of stuff. So I've still got my Pi application. That hasn't changed. My to-do app hasn't changed with the WebSocket stuff in there. I've got two parts for my blog.local. So the first one is listening on port 80, so standard HTTP, and it's going to redirect to HTTPS. So any request that comes into http://blog.local will get sent a 301 response telling it to go to HTTPS. So that's a standard HTTP to HTTPS redirect. Just a nice way to force people to upgrade to my secure version of my site. And then that's in here. So it's still listening on the same endpoint, but it's using 443. So this is HTTPS. For that to work, it needs a certificate. And I've just got a self-signed certificate that I'm passing through here. Notice the Nginx file gets more and more complicated as you're adding more and more stuff in, but at least it's all in one place. So all the configuration for my different applications lives in here in this static file. And this increasingly weird stuff here is if you go to one of the SSL checking sites and verify your own application, it will tell you all the cipher suites and stuff that you need to implement to be up to date with the latest security. And all that stuff fits into Nginx. So I can tell it exactly the type of TLS communication that I want to support. And the last thing I can do is I've got my location here, saying that any requests that come in, they're going to be served by the Ghost container on a different port. That's fine. I've got my stale caching. I've got ordinary caching. And I've also got this block in here, which says if people try and browse to the /ghost endpoint, they're going to get a 404. Now, in reality, this deny all block would be like an IP whitelist or something to say certain users can access it, but most people can't. So I can block all access to this. So again, I'm exposing all these applications through my proxy, but I'm doing it in different ways to support whatever features I need to have. And let's clear these down. Oh. This is why I do copy and paste, so I don't end up with things like Ocker. There we go. Let's get rid of my individual container. And if I bring all these up again, and that compose file is just... If anyone wants to come up and actually do the demos for me, that would be useful. D, thank you. I'm going to start with a D. Sorry, I'll be there in a second. There we go. D. Hey, okay, so the compose file is the same as before, effectively. I've got my nginx. I'm passing in the configuration file, which is the one I've just shown you. I'm also passing in my certificate, so my local certificate file and my local key, so it can serve up SSL. I've got my Pi app, my to-do app, and my Ghost app. So even though there's more and more complexity in my static configuration file, my deployment file, which is my Docker Compose, all these components are very, very simple. All I'm doing is running containers, and the access for those containers and how Nginx is going to work with them is all being specified in that conf file. Okay, so let's just check all this stuff works. I'm going to open a new window, because I've probably got redirects from a previous session. So if I go to pi.local, zoom in. There we go. So that's working. Whatever the other one was to do. Oh, no, I don't want to browse to Google. New.local. What is tot, anyway? Definition of tot. Tot, yeah, anyway, right, okay, and blog.local. If I visit blog.local, it's going to redirect me to blog to the HTTPS version. So this is coming into Nginx. Nginx is looking at its rules and saying, you need to go to HTTPS. So I've already accepted the fake certificate that I've used before. So I'm seeing that there's a certificate warning, but now I'm on the HTTPS version. So I can see all this stuff. It's still coming through, ultimately through my web container, but Nginx is applying the security layer. And if I now try to browse to the Ghost endpoint, then I get a 404. So all the different pieces that I need, I've still got the caching in this web application, I've got the routing, I've got all the load balancing, all that stuff that I need, but I've also, in this one specifically, I'm banning certain access to certain parts of the application. Okay, so that was that. So the Nginx stuff is interesting because it fits in really nicely with this sort of model. All the features that I've demonstrated, they're all pretty straightforward. I mean, the Nginx configuration syntax is a bit clunky, and it takes a little bit of getting used to, but it's quite an old technology, and there's stacks of good content out there about how to make the particular configuration that you want work. So when you take it on board, actually, there's a lot of resources behind you. All the stuff I've shown, routing, load balancing, caching, SSL, all in that one configuration file. Different things applied to different applications depending on what I want to achieve, but it all lives in there inside Nginx. And if this looks like there's a kind of single point of failure, well, Nginx can run in multiple containers too. So I've got high availability on my ingress into my application cluster. And of course, because I'm also allowing stale content, I've got some more availability if my application container goes offline. The most common parts of that application can still get served from the cache. The disadvantage with this is that this is the world that Nginx grew up in. So it was originally built to work into virtual machines and a network segment where Nginx would live in the DMZ and everything else would be internal. All that's actually different are the host names. Like the way Nginx works is exactly the same. All the same features are there. So you can deploy this anywhere. The disadvantage with that is everything has to live in that static config file because Nginx doesn't know it's running in containers. It can't do some of the more advanced stuff that modern reverse proxies that are built specifically for a container platform can do for you. So you have to explicitly put all this stuff into that configuration file, which is where Traefik comes in, which might be pronounced Traefik or Traefik, I'm not sure. I use both indiscriminately, and that way I'll cover the bases. So Traefik is a container-native reverse proxy. So it was born after Docker. It's meant to run in a container, or it's meant to run in Docker or Docker Swarm or Kubernetes. What Traefik does that's different is it connects to the container platform. So if I'm running in a container, I can talk to Docker, or I can talk to Kubernetes, and I can find out about other containers. And what Traefik does with that is it builds its own routing rules. So I tell it where the incoming endpoints are, and it works out which containers it's going to send the traffic to. So it's got its own dynamic configuration. I don't have this static file that I have to make sure I keep updating. And if I update it on a running container, I might have to restart the application. I don't have any of that. All that's done for me. It integrates really nicely with all the main orchestrators, and even ones that aren't main anymore. So it just plugs in with the API that supports the container, and it finds out the stuff that it needs. And it has the same model. Like it's open source and free to use. There's a commercial element if you want the supported side. The diagram is exactly the same. So Traefik's been replaced Nginx. It can still do all the same stuff, all those same patterns about microservices and selectively exposing elements and decomposing your monolith. It all works in the same way. But the difference is that Traefik plugs into wherever it's running. and it makes a connection to the API, and it gets the information it needs then to build up its own routing rule. So it's got that element there to save you having to build that big config file. Doesn't mean there isn't configuration. It just sits in different places. OK, so let's show you how that looks. So back in Visual Studio Code. So now for this demonstration, I'm going to run the same set of apps, but I'm swapping out my reverse proxy. So instead of Nginx, I've got Traefik. So I'm running Traefik in a container. I don't have a configuration file, but I can tell it all the interesting things that it cares about in the startup of the container. So this is a command line application, runs in a container. These are all the switches that I'm providing it, which tell it that it's running in Docker Swarm. This is the network it should use for the containers. These are the addresses it should listen on, 80 and 443. So it's going to run there. This is how it's going to run and connect. This is the bit that lets it connect to the Docker API. So when I'm in a container, I can hook in to the Docker engine that I'm running on, and I can find out about other containers, which is how Traefik's going to build its routing rule. Now, my other web applications, they're mostly the same. I'm just got the image to tell you which application to run. There's no ports being exposed. The only ports are from the reverse proxy. But in this case, I've got these labels here. So Docker and Kubernetes, they all have this label idea where I can apply any arbitrary key value pair to a container. And that's what Traefik's listening for. So it hooks into the API. When a new container starts up, it queries the API to see if it's got any of the labels that it's interested in. And if it has, then it uses that to build up its routing rule. So as containers come and go, and as they start up on different servers, as I scale up and scale down, all those events are being fed into Traefik. It's updating its rules. It's constantly up to date. So there is still configuration, but it lives inside my deployment document, my Docker Compose file, so everything's in one place. And all my apps are the same. So they tell Traefik which host name to listen on, which entry point, which is either HTTP or HTTPS, and then the port inside the container. So they're all this is the same configuration as the previous deployment, but swapping out the proxy. OK, so I'm running this in, where am I down here now? I'm going to run this in Docker Swarm mode. So I need to get rid of all my containers. Make sure I get the D. OK, so clear everything down. So Docker Swarm, if you're not familiar with this stuff, is an orchestrator like Kubernetes, but it's built into Docker and it's super easy to spin it up. So now I'm in Swarm mode. I can deploy that Docker Compose file that we've just seen. It's going to start up all those things. The other thing that I've got in here is I've got a replica level for my Pi app. So whereas I manually scaled up before, I've captured that in my deployment document. I'm going to have 3 instances of my Pi container, and by default, 1 of everything else. OK, so everything's up and running. Back here. So if I browse to those same URLs again, so my Pi. So I get this, as a user, I get the same output. So I still see exactly the same thing. I'm not really interested in what's happening behind the scenes. I still get the same kind of output. If I repeat this call, now I'm going through Traefik. I've got the load balancing, so you can see the container name is changing, but I don't have caching. So the one big thing that Traefik doesn't have, that Nginx does have, is the response caching thing. Now, Traefik has this middleware architecture where things can be injected into the pipeline. So caching will probably come along at some point. But right now, the cost of moving to something that gives you the dynamic configuration is that you don't get caching at the moment. So some people run Traefik and Nginx, and they use Traefik for everything else and Nginx just for the caching. But all my apps are up and running here in the same kind of way as before. Let's just check this. Oh, no, don't do that. That's why I need to go into my private site again, don't I? If I go to my blog.local, oh, let's go here. I'm running the wrong demo. So in my Docker Compose file here, so I haven't got caching, but I have still got the load balancing and the routing side of things. If I want SSL, I can do that with Traefik as well. And there's more stuff that I put into my Docker Compose file to make that happen. So I'm already listening on port 443. I'm already telling Traefik that a potential entry point is HTTPS. And then I need to do the redirect stuff that I did in Nginx. And the way I do that in Traefik is with more labels. So there's more and more stuff that goes in here. Just like the Nginx configuration got more and more, with Docker Compose, I could put these into separate files and join them together if I wanted to. But what I'm doing here is I'm saying for my HTTP endpoint, I'm still listening on pi.local. But I'm going to redirect everything using this middleware component that will redirect everything to the HTTPS endpoint, which is then configured down here. So this is saying same host name, but this is coming on 443, and that's going to be secured. So a whole bunch of extra stuff in there. What I don't have is I don't have any certificates. So Traefik has this really nice concept of certificate providers. If I don't give it a certificate provider, it will generate its own. So I get the same impact as when I did a self-signed certificate with Nginx, but I had to write my own certificate. For Traefik, if I don't get a certificate, it will just generate one for me. It's still self-signed, but it takes care of that. But it also, that other providers can be your own set of certificates, or things like Let's Encrypt. So it will connect to Let's Encrypt and get you a free HTTPS certificate and update it every month or however often it needs to be updated. So it'll take care of all that stuff for you. And then again, that's just part of how the configuration lives inside your Docker Compose file or your Kubernetes YAML file. So let's go and do this, and we'll see the HTTPS stuff kicking in. So when you do these sorts of deployments with your container platform, I've got a single machine that's my Docker cluster. It would be exactly the same Compose file if I had a machine with 100 servers, a cluster with 100 servers, and the same deployment command. So it would just fan my applications out across my entire cluster. And it does like the Compose file is the desired state. It looks at what's currently running. It sees the labels have changed, and it'll make the update. So now if I go back in here and do the right thing, and I go to pi.local, that's now going to hit the redirect piece of middleware, and even though it's ultimately going to the same application container, it'll go through and say you need to go through HTTPS, and this is the warning I get. It's a self-signed cert for a completely different domain, which is fine if I'm just a developer, and I want to make sure that HTTPS doesn't actually destroy anything, and everything works the way it should. And again, if I do this still works, and if I refresh, I've still got the routing, the load balancing, all that stuff. The SSL just comes up first. Okay, and the last thing, to show you how Traefik kind of integrates with the platform that it's working on, is to do this exactly the same thing in Kubernetes. So Kubernetes deployment files are a work of art in themselves, but it's the same principle. I deploy my applications, they're private components. So in the Kubernetes world, I deploy my Pi application as a deployment artifact. This is the image to run for my containers, and then I have a service which allows network traffic in, but only within the cluster. So this isn't publicly available. My Pi application is going to be running in a container that other containers can reach, but the outside world can't. Same architecture as I had with Docker, but just 10 times as much YAML to define it. And then if I want to deploy Traefik, I've got Traefik itself is going to run in containers, and this is how it connects to the Kubernetes API with the rules of what it's allowed to do. And then Kubernetes has this concept of ingress is a first-class idea. So the idea that certain requests come in for a certain host name are going to be directed in some way by a reverse proxy component. And this is saying that this is, again, I've got configuration here, but it's the configuration of the platform. So when I'm working in Docker, I use Docker files and Docker Compose files to deploy my labels, which Traefik uses. When I'm working in Kubernetes, I have a Kubernetes ingress document. So this is just saying the same stuff. When I've got a request for pi.local, you're going to send it to the Pi service. So I'm living in the Kubernetes world. I'm not having to master another set of configuration, which would be the Traefik configuration. OK, so let's just do this. We'll see the final thing. It's going to be exactly the same demo. I don't really know why I do all these demos, actually. So I should just do the same one, just pretend to run the commands. So I'm getting rid of all my containers. I'm coming out of swarm mode. And then I'm going to deploy my application with Kubernetes. So kubectl is the Kubernetes command line. Some people pronounce it differently, but they're wrong. That's the apps. This is Traefik itself. And these are the ingress rules. OK, so all those things living now in my Kubernetes cluster, and the way that I work with them is exactly the same. I haven't got all the extensive configuration that I put in the other deployment. I haven't got the SSL or any of that stuff, but I could if I wanted to. I would just be extending the stuff that goes into my Kubernetes manifest. And again, all those apps are working in the same way. They're still being surfaced by Traefik. It's the same Traefik container image, but now it's running under Kubernetes. And Nginx also has support to run in Kubernetes as an ingress controller. So if I want things like caching, I can go to Nginx in my Kubernetes deployment rather than Traefik. OK, so that was the last demo here. Okay, so with Traefik, same architecture. I've got everything in the same except the caching, but the trade-off for that is the SSL integration is much better. So the fact that it will own the communication with my certificate provider. Let's Encrypt is a really good one because free TLS certificates, they're only valid for something like 3 months, and then you have to rotate them, which is a great practice to do unless you have to do it manually. But if your infrastructure does it for you, then it's great. You don't get the caching with Traefik, which you do get with Nginx, but you can run it with high availability, and it kind of works in the same way. So the same concept applies for Docker Swarm and Kubernetes. I can say on every single one of my servers, I want to have a Traefik container. So every server's got a local Traefik container, and it will find the upstreams wherever they may be on the cluster. Okay, so benefits of the reverse proxy. So you've seen it's a kind of centralized way to take care of those infrastructure concerns. So SSL is a good one, HTTP headers, giving client headers so that they can cache on the browser, all that sort of stuff. You don't have to have any of that in your application, particularly important if you've got lots of different application platforms, because they all do things in different ways. So you can forget about that. Your application just publishes plain HTTP with whatever default response headers come from the platform, and then you take care of the rest of that stuff inside your proxy configuration. Performance should definitely improve because you're taking all the boring stuff away from your application containers. So you're not asking them to render CSS and JavaScript and plain files. All that's going to live in the proxy. And the most common things that get requested will be in the proxy cache. And so they'll get served most quickly. And then potentially HA as well, to give you a little bit of extra support if part of your application goes down. The most common things can still get served by the proxy. And then native container ingress, which actually sounds really impressive. It just means when I'm running lots of containers, they can't all listen on port 80. There has to be one thing listening on port 80, and then doing the routing between them, and that's what the reverse proxy does, no matter what technology you're using. And then this idea that my application containers now become private components. Especially important if I'm taking old applications and I want to run them in containers. I don't necessarily just want to make them publicly available because there may be any amount of defects or vulnerabilities in there. So the only thing that's public is my proxy, and then I can configure how it talks to the upstream apps. So it enables some of those patterns that I've talked about, being able to route between multiple domains, enabling microservices so that you can selectively publish different things, gradually decomposing your monoliths. Not something I focus too much on, but the idea that I can have my monolithic application with 10 million lines of code. As I'm working on individual features, I break them out into separate containers, and I route the traffic appropriately using my reverse proxy, which means I don't do a big rewrite of my application. I don't take my monolith and I stop for 2 years to rewrite it and then release a new version which is exactly the same, except that some things don't work because we didn't realize how it was all fitted together. Instead, I'm just taking the features I care about most and I break them out, and I plug it all together using the reverse proxy. And then once you've got that stuff, there's some more advanced patterns that you can start looking at. So the idea of an API gateway is really just a reverse proxy that's kind of tuned for API payloads. Both Nginx and Traefik support gRPC as well as HTTP, so you can do REST. You can do REST APIs and get all the same sorts of caching benefits, and the same with gRPC. And WAF, anyone not familiar with what WAF stands for? Ah, okay. So it's a web application firewall. So the idea is the incoming traffic comes into my reverse proxy. I can put security logic in there as well. So if I've got an old application that I know is potentially subject to SQL injection, I can put SQL injection protection in my proxy. So Nginx has like a WAF module that you can load in that does things like all these attacks have a similar look and feel to them. So if there's an HTTP post coming in, and in the payload there's something that looks like a SQL injection attack, the proxy will just send a 500 response. It never reaches your application. And there are different levels of different attacks that you can put in to your web application firewall. So your proxy becomes like super important in protecting your application code. Okay, so a whole bunch of links. All the demos from today are up on GitHub. That README document that I went through, feel free to add some more Ds if you need to. If you're from a .NET background and most of this stuff didn't make sense, the Docker and the Kubernetes stuff, which I had to kind of skip over. That DAC for .NET, that's a workshop that I do, but all the content's online. So I'm doing it Saturday if you're still here, but if you want to, you can work through it yourself. This fetching t-shirt that I'm wearing is my new book, which is almost half finished. You can go on that site and you can buy the early access program, and that will give you 40% off. So thank you for listening. My name's Elton. I'm around for the rest of the conference. I hope you enjoy the rest of Build stuff, and if you're coming to the workshop Saturday, I'll see you Saturday. Thank you.